All right, so we'll get started on the core material then. So this is a Go with MongoDB presentation, not React, yes. Sorry to disappoint again. So this is kind of what I do full time during the day. So I'm a developer advocate at MongoDB. I also love the Go programming language. So this is should be interesting. So because there is new faces here. So like I said, developer relations at MongoDB. Some of you overheard me say that I am an author at the Polyglot Developer, which is my blog, organizer of this particular meetup group, and then overall technology and video game enthusiast as well. So the agenda, hopefully by the end of it, you have some familiarity with developing Go applications with MongoDB, but we're going to see how to deploy a cluster. For this example, we're going to be using Atlas, which is MongoDB's cloud instance of MongoDB rather than seeing, say, Docker or some kind of on-premise. We're going to be looking at connecting to said Atlas cluster, doing basic CRUD operations, so create, retrieve, update, and delete, which is pretty critical for any kind of back-end application. Then we're going to kind of apply that towards RESTful APIs and GraphQL APIs. And please stop me if something doesn't make sense. I know that is this everyone's does anyone actively use Go? No. All right, so yeah, so feel free if Go looks odd or doesn't make any sense, stop me on that. MongoDB experience? A little bit. All right, feel free to stop me on that too. So like I said, we're going to be using Atlas. It's going to be used throughout. There is a free tier. You can use an M0 cluster. You'll never have to pay for it. No credit card required. If you think that you may someday want to get a more expensive cluster, sit on my coupon credit here. Apply it towards your account. It's not restrictive to new accounts. And to my knowledge, it never expires until you use it. So if you want to sit on some $200 credit, it's not bad. And I'll put the code up at the end too. So deploying with Atlas. So the first step, so this is kind of a screenshot walkthrough. It's a very short process. So you would go to cloud.mongodb.com, you would create an account, sign in, and you would be presented with the option to deploy a new cluster. You have three regions here. You have AWS, Azure, and GCP, which is Google's. Why might you have three? Well, if you're an AWS shop, it probably doesn't make sense to spin it up on Azure or in the other direction as well. Not only that, it's also a little easier when it comes to firewall rules. So if you're on Azure, it's probably a little easier to put your database on Azure too. Likewise, distance-wise, if you're on the same kind of space or zone or whatever DevOps kind of related terminology you would use, if you're in the same space, it'd be faster latency between the cluster and your applications. After you choose your cluster, which maybe it's M0, maybe it's not, you are presented with a dashboard. So the dashboard is where you have the opportunity to explore that cluster, get metric information, you get to create accounts, set up network rules, a whole lot of good stuff. So the first step is you might want to create a network rule. By default, nothing is on the safe list. Every connection to MongoDB Atlas is going to be denied. So you'll want to add something to that safe list. You probably don't want to add what I have here. This is a generic kind of all access kind of IPs thing. It's great for me to develop with, but in production, you're opening yourself up to problems. Yeah, so look for the IP range for whatever application you're using and apply it. What's up? Which? Oh, I couldn't hear you. Slick grabs? Never heard of it. I'm sorry. You making stuff up?
No. There's a company that sells like stickers
for
your phone and stuff.
Oh, all right.
They're huge, and they were hugely hacked today. There was an article about how terrible their security was, how they hacked them. It was awesome.
Well, maybe they didn't set a network rule. Or when it came down to account creation, maybe they gave a little bit too much permission, right? So you're going to want to create an account hopefully for just your database. This circumstance right here probably is not something you want to do either. You don't want to create an account and say give it access to all databases, read and write. you could easily click that default, that little text below, and it'll let you define exactly what database you want to give this user access to, specifically what collection you want to give this user access to, and everything is magical at that point. You could also, one of my favorite features when it comes to actually making videos and stuff, or stuff that I need to teach, is there's actually a self-expiring user account that is useful for my own circumstances. Could be useful if you want to give like a consultant access to, say, expire this user account in 6 hours or something, so that way you don't even have to worry about cleanup, which I personally think is pretty cool. So you have your Mongo instance ready to go, hopefully. Now you need to worry about your data model and what do you plan to build with your application. So this is, let's imagine that we're building a podcast application. We are expecting podcast shows. We're expecting episodes for those shows. So the show document could potentially look something like this. It's not too basic. It's got an array in there. We know that MongoDB is NoSQL. It's a document database. You're working with JSON. It could be complicated if you wanted it to be. But let's just say we're going with this for now. Now let's say this is what an episode document would look like. In this particular scenario, we have a podcast field that, let's just imagine, is referencing the podcast show document. So the previous document, which exists in a different collection. So if we wanted to do a join, we could do a join, even though that's a document database. But we know that this is a document database. We could complicate things a little bit. This is another way that we could look at storing the same data. So for example, maybe we have a show and we have an array of episodes inside that show document. That's fair game as well. Or here's another way that you could look at it. So maybe you want the show information inside of every episode document. So another very valid way to store your data, MongoDB. We're going to be looking at the first two examples where they are separated. So episodes in one collection, podcasts in the other collection. We good up to now? Yeah. All right, so I think it's small. I don't know what's on the screen there. There we go. This is what it would look like in MongoDB Atlas. It does have its own data explorer in case you didn't want to use a like Compass or some kind of third-party tool. So this is kind of a rough example of what I had shown in the slides. This is BSON, of course, because that's what MongoDB uses rather than JSON, but the format is very similar. So let's connect to MongoDB with Go. So this is where we get into the Go stuff. So first off, you want the MongoDB Go driver. There's many ways to get drivers in Go. You can use Go Get, which would kind of get it globally for all of your projects within your Go path. There's dep, which a lot of people use. So this is the Go dependency manager. Works kind of like npm. You get a YAML file with the version. There's Go modules, which is newer. But for now, we're going to use this one, dep. It's common. So we get that Go driver. Now we want to connect. So we use a context, which is very common in Go. So we define a timeout that we want to use. So maybe the connection stalls, maybe some kind of query stalls. We want to time that sucker out in 10 seconds. We apply it in the connect function of MongoDB. And we provide it the URL to our cluster. In this case, os.getEnv is an environment variable on my computer. It's very common with pretty much all cloud providers nowadays. You could use Lambda and set some environment variables, EC2. Even GitHub lets you set environment variables probably right now. So it's probably better than hard coding it in your application because it does contain username and password information like that you defined in the previous setup stage. If it fails, it'll panic. Otherwise, when the function, the parent function that this code resides in terminates, then this defer is called and it disconnects. So defer, you can place a defer line anywhere inside the function. It won't execute until that function terminates. We can test that the connection was successful. We can ping it. So we ping it. This readpref primary is saying we want to ping the primary node in the cluster. If it panics, it wasn't able to connect to that node. If it doesn't do anything, we're probably good. Or we could list the database names. Maybe ping is no good for us. So what we could do is we could provide that context. We're also providing BSON M. So BSON M is a map. There's other data types as well, which I'll talk about. But BSON M, being that we're not providing any kind of data in that interface, it's a kind of like a wildcard filter. So it's going to return everything that this function can. So it's going to list all of our databases in our collection. And we'll get more onto the filters in a second. We good so far? Sweet. All right, CRUD. So this is the most essential part. So we have a connection to the database, or to the cluster. We want to get a handle to a particular database, because you could have many databases in your cluster. And then we want to get a handle to some collections in that particular database, because you could have many collections as well. So we're following the lines of podcasts and episodes. And more on the types. So BSON M is a map. It's more similar to just a Golang map. We also have BSON D, which is document. The primitive is for object IDs. So you could easily set your own object or your own ID values for MongoDB for your documents, or you can use an object ID, which is a hash. And then there's A. So the difference on D and M, because this is important. So some filters, the order of the operations matters. In a map, there's no order. So in a document, a BSON D, the order that you place things in the document will remain that way. So this is mostly important for, say, a range query. So if you're saying field greater than something, the order matters because the way it's structured. And I'll show it as we get there too. Same thing with aggregation queries. But if you're just doing something simple like an equality query, like x equals y, map is fine because it doesn't really matter what the order is. And it's also relevant when it comes to your indexes as well. The order matters. So here's a D, a BSON D document. So we could easily do this. So this is kind of like some wonky kind of JSON here. We've got commas instead of colons. But for the most part, I have very flexible kind of fields here for this document. And this would represent what I had shown in the previous slide of the model. If I wanted to insert this, I would say whatever collection I have the handle of, I would say InsertOne. And I would choose to insert it. If that insert failed for any reason, I'd get an error. Otherwise, it would print out the ID. So that ID could, again, be an object ID, which in this case it is because I never set an ID, or the actual ID. That's just a it's just a value, so it'll print out whatever that value is. It's a formatted print statement. I didn't have to do that. I could have done a print line instead. It would have accomplished, for the most part, the same thing. When, with pluses separating the strings. Because you don't have, at least I don't think so, I don't think you have the option to set kind of $ bracket like you do in JavaScript. So this is an option. We can do it this way. This way is my preferred approach to things. So I like everything to be very strict when it comes to my data. So I could create a Go data structure, kind of like TypeScript interfaces. So I would create a Go data structure. The important piece here is the annotation, so where it says BSON. So the BSON is saying this BSON field in the database is mapped to this data structure field in Go. You have other annotations in Go. You have JSON, you have XML, CSV. There's a whole lot of things that you can do, and it makes it very easy to manage multiple types without having to do all kinds of crazy serialization and things like that. So in this state, I could then use my data structure, so on and so forth. Advantages of using this. Well, you get type ahead in a lot of circumstances, something that you wouldn't get with BSON D because it's so flexible. You get compile time error reporting, something that you wouldn't get with BSON D because it's going to detect if your fields are off. You get a whole lot of other stuff as well. The omit empty. So when you don't have omit empty there, if I were to create a data structure here, let's say that this bottom part, let's say that I didn't include author being a string. If I didn't include omit empty, the default value for a string is just an empty string. And if I were to push that up to MongoDB, well, now MongoDB has a field in that document with an empty string. If I used omit empty, that field just won't exist at all in MongoDB. And there's a lot of circumstances where it would be important when it comes to querying. And then you would insert it the same way that you would with the BSON D. And you could use either or. My preference is just to use data structures here. But you get the same inserted ID back. Does that make sense so far? Here's another option that you can do. So the inserts, the finds, the updates, the deletes, they all have a one form and a many form. So if I wanted to insert many documents in one operation, I could do something like this. I could also provide data structures, but I'd basically be providing a slice of interface to signify that I'm doing more than one. And instead of returning a single insert ID, I'd get an array of them back. And in this case, I'm just printing out how many came back. Yeah.
Is that saying that there's an array of an interface of some type and then you're defining?
Yeah, so in this scenario, the interface right there, that's kind of like using an any, right? It's any kind of interface. So a data structure at the end of the day is an interface. So anything. So it's just very generic. If that, yeah. And instead of doing array like you would in another language, you do have to use the brackets in weird places in Go.
I guess it kind of makes sense, right? It's an array interface and objects.
Yeah.
It's cool.
Yeah, it's a little different. It takes a little time to grasp. I always forget the first braces, the first curly brackets. It always messes me up because the error, for whatever reason, is not very specific that's my problem when that is. I don't know. It's like forgetting the semicolon. There's no semicolons in Go, so. The other side, the problem is that I do a lot of JavaScript, so I do add the semicolons, and then it complains at me for adding the semicolons.
It's not like JavaScript where it just doesn't care.
Yeah, basically. So find, this would be the equivalent of say find many. There is no many at the end of this. There's also a find one, but in this case, we're using a filter. So this one's BSON M. Doesn't matter the order of the properties. I could have multiple properties in that find. In this case, its duration has to equal 25. I could say comma author equals something else, so on and so forth. The order doesn't matter because I'm using a map. I'm storing the result, or actually I'm not storing the result. I'm getting a cursor back, and I'm defining a slice of episode. So when I use this cursor.all, I'm loading all of the results into that slice. That's great if you don't have millions of documents coming back. If you do, that'll probably cause some kind of problem for too much data coming in. In that case, you probably want to iterate over the cursor instead, and that'll get the data in batches. So you have options. In this case, what I'm doing, same query. I'm deferring the close of the cursor until the enclosing function terminates. And I'm just iterating over them one by one and decoding them and printing them out. So depends on what your use case is, and especially if you have tons of data.
Does it not fetch the data until? So like, is the data loaded into memory if you have like 3 million results? Would I still get a Stack Overflow, or would it just
like if you want to iterate over a cursor?
Yeah.
So I think it gets the Lourdes might know more because it's a common thing when it comes to databases. It's not specific to MongoDB. I think it just keeps track of the page.
Wow. Okay. That's really cool.
And then it just increments and pulls them back according to the batch size. Is that how most databases do it? You never used cursors before? All right. I used them in Oracle a long time ago, PL SQL.
I've used it with GraphiQL.
Yeah.
I wasn't sure if that was like a universal concept.
Yeah. Maybe.
Very cool. Makes sense why GraphQL is integrated.
Yeah, there you go. We'll get there in the end. Update. So update, a little different. So this is an update many. Like I said, there's an update one as well. The first one after the context is my filter. In this case, it's an equals filter. So I'm saying the title has to equal the Polyglot Developer Podcast. In this circumstance, it's probably unique. It doesn't have to be unique because we want to be able to update multiple documents. And then what comes next is the set. And this is where the BSON D is relevant because I could have multiple kind of operations there, and they could get a lot more complicated than just a set. They can start nesting quite a few times and get a little out of hand sometimes. But in this case, it's saying it's going to set the website. Website property can exist. It doesn't have to exist. Either way, by the end of this operation, if there's a match, there will be a website set at that value. If you wanted to, though, you could do a replace instead. There's a replace operation. Instead of updating a certain field, you're just swapping out the whole document. So whatever matches. So it's whatever meets your needs. All right, finally the delete, the last part of CRUD. So very simple, provided that same operation for the filter. There's a whole long list of operations that you can choose for filtering. And they can get pretty complex when it comes to arrays and things like that. But prints out the deleted count. We good up till now? Sweet. Now let's start moving that into an API. So maybe we want to develop a Go application that serves as a REST API to React, Angular, Vue, who knows, whatever, any kind of client. So you could use the HTTP libraries that come with Go. There's nothing wrong with that. I find that it's easier to use this web toolkit. It makes things particularly easier when it comes to working with route parameters. So not query parameters, not payloads, but the actual route parameters. It parses them differently. It's just a little easier. They share a very similar API, the default HTTP package versus this toolkit. But in this case, I'm using the dependency manager for Go to install it. And imagine that comment was our previous MongoDB connection logic. We need to define the actual endpoints and the functions that those endpoints should go to. So there's some debate in Go whether you should use global variables to represent your maybe connection information for your entire application, or if you should pass that connection information in as needed. I don't know which one is the correct way to do business. I've tried them both. They both work for me. But in this case, I'm passing it in. So I'm creating a connection struct. I am defining the collections that I plan to use in each of my endpoint functions. Let's assume that inside that MongoDB comment there, I've obtained a handle to my database, I've obtained a handle to my collections, and I've created a connection variable that has both of my collections in it. Now I'm passing it in. So I have each of my routes, I have each of my functions that I'm going to show in just a moment, and I have the type of data that, the type of request it is. So post being for create, get being for read, put for update, and delete for delete. So here could be an example of the create endpoint. So this is just for podcasts. I didn't create any endpoints for episodes because they're more or less the same thing. But we get that connection, and in Go it's a little weird. You can pass in variables before the function and after. It's maybe like prototyping in JavaScript, since I think a lot of you are JavaScript people, right? That's similar, right? The connection up front. You see function and then connection. Does that look similar to function variable prototypes? A little bit? I don't know. That's the way I've always looked at it. Could be. It's weird. It took me a while to grasp this concept, though, but it's adding a function to this particular data structure. So this function being CreatePodcastEndpoint. I guess it could be.
Connection is a type connection, and then you're adding it to CreatePodcastEndpoint.
Yeah.
So you can do CreatePodcastEndpoint.connection.
No, it'd be.
Just use it inside of it.
No, it's like. See, I'm saying connection.createPodcastEndpoint there.
The other way around. Gotcha.
Yeah.
Yep. Okay, that works.
That kind of thing. So that way I could actually use it inside of the function.
Yeah, I had it backwards.
I'm setting the response type as JSON because that's typical format for APIs. I'm defining a podcast variable. I am taking the payload, since this is a create request, I'm taking that payload, decoding it into my podcast variable. I'm not doing any kind of data validation, which I should be, but I'm using a context, and I am calling InsertOne based on the payload that came in. It'll do like the most basic validation, because if I've created a data structure and I'm receiving fields that don't exist in that data structure, they'll just be dropped. But if you're concerned about what values exist in those fields, then you got to worry about that with some kind of validation.
Also, I think you're right. I think it is very similar to prototypes.
All right, so I'm not totally crazy then.
Because I was like, I thought that connection modified
Yeah.
the body of the function somehow. It's like, that's decorated.
I'm trying to make it relatable for sincere a lot of JavaScript people. If there was no error with that InsertOne, I'm going to return the result being the inserted ID, and the client can do whatever they choose to do with it in the end. Here's GetEndpoint. So very similar. What I'm doing is, because I've chosen to make this GetEndpoint a getAll endpoint rather than get based on a particular ID, creating a slice of podcast. I am doing a find. I want to get every document in that collection, so I'm not adding anything to the filter. And in this case, I'm being a little lazy here, and I'm just doing all. I'm not worrying about any kind of paging variables or anything to kind of make it smaller requests. So I'm doing all inside the podcast slice, and I am returning it as is to the user. Update. So this is a little different. So this is where we get more in depth with the Web Toolkit. So in this circumstance, we have a theoretical route parameter. So the route parameter is maybe the ID. And then the payload for this particular request is what we want to update. Let's assume that I am using object IDs rather than kind of hard-coded string value IDs. So I need to convert it into an object ID before MongoDB can make sense of it. Decoding the payload that came in for podcast. And I'm doing the update one. The filter is, of course, the ID that we've already transformed. The set, because we are using omit empty, we're only getting back, or we're only sending up values that have data, right? So in this case, say only author was provided by the client. Then only the author is going to get updated here, because everything else is nil or null or doesn't exist. So this is pretty cool, I think. And then it sends back the result being what was the modified count, how many were matched, things like that. And then finally, delete. So delete, maybe we have a route parameter again. We convert that into an object ID. We call delete. Should only be one. And we return the result, which would hopefully be deleted 1 as the result. So we good up until now? All right, so the GraphQL stuff. So this is where it turns into a little bit of a plug. So you could easily create your own GraphQL API with Go. It would be really no different than what we did for the REST API. You would get some kind of third-party library maybe, or you create your own, and you start developing your own resolvers, your own schemas, all that good GraphQL stuff. With MongoDB, there's actually Realm. So Realm is something that MongoDB is pushing right now. It's baked in GraphQL. So what it does is it connects to your cluster. It looks at your databases, it looks at your collections, and now it acts as a middleware service that you don't have to create yourself that runs GraphQL queries. So it's pretty neat in that sense. So this is an example with GraphiQL, which is a common client for GraphQL. You get your GraphQL endpoint. It's already looked at my collection for, in this case, podcasts. So I would have all of the fields, and I could do GraphQL queries from any kind of application, including Go. To be more specific on setting it up, you would have to create a GraphQL schema because it unfortunately won't allow you to be as flexible as you can with a document database. So you would have to actually define the schema for GraphQL to work with. You can do that yourself. You can click that generate schema and it'll do it for you. It'll just look at all of your documents and pick what's appropriate. If I wanted to, I could access that GraphQL API from my Go application. Let's maybe assume that I'm not developing a kind of web service Go program. Maybe I'm building an IoT application with Go. Maybe I'm doing something else and I need to consume GraphQL data. With MongoDB, you would authenticate first. So you do have to authenticate. It does offer anonymous authentication in Realm. It also offers other forms of authentication. In this example right here, it's anonymous. I just didn't provide the URL. But I would get an access token back. So access tokens are pretty common when it comes to APIs. So I'd get an access token back. And then I could go ahead and use it in another request. So in most implementations of GraphQL, it is just an HTTP request. So same like any kind of API. The only difference is you're providing it a query as well. So I could have easily created a data structure with my query. I've just chosen to use a map here. In this case, I'm doing a GraphQL query with podcast. It could have easily been a mutation as well. I'm making a post request. I'm including the access token, and I'm not doing anything with the result in this circumstance. I could print it out. I could return it somewhere, whatever you can think up, but it would exist in the response body that we're reading. Does that kind of make sense?
Does the Realm GraphQL instance host the schema from a publicly accessible method as well?
I don't know.
The only reason why I'm asking is that you can generate like TypeScript typings using the schema of the GraphQL server.
It might. I mean, it has the graphical client, right? So it doesn't graphical do the same thing that TypeScript would? I think it might, because if I brought up, I use Chromical in Chrome. It's an extension, so that way I don't have to walk around with graphical. But I imagine that it would identify my schemas the same way. I think so. So I have a little bit of a demo, just more or less just a recap than anything. But let's take a look at my application here. So this is actually the application that I pulled into the slides. So there's no trickery here. It's exactly what you've seen for the application that I just talked about. What you'll notice here, though, is I'm not including any JSON annotations, and you'll see where that becomes relevant in a second. But if I open up Postman here, oops, and if I run this, if I say get podcast, for example, what was that?
That started fast.
Did it?
The server, yeah.
Oh.
You should have to wait like a second or something.
Really? It's like instant in Go. Yeah. So notice the properties. Just take note of them for a second. They're exactly the same as the fields, right? With the same capitalization and everything. It's because I didn't include the JSON annotation. It doesn't know how to map them as JSON, so it's just using the field name. If I were to add a second annotation here for JSON, and maybe I chose to use lowercase ID or underscore ID, then I would get those here. So that's just because I failed to include them. But for the most part, it still worked. It's still a very capable API. If I wanted to, and it might make me log in. Let's see here. Give it a second. we having some internet issues. We might be having some internet issues.
I don't think they're using Go. I
No, I don't.
I think it's PHP.
I had a little. I had
I
a.
think it might be the computer. Is that Apple?
This
Is that Apple?
this guy's always telling me it's my computer. I don't think it's that.
Man, look, I'm streaming right now. I don't have no problems.
No? All right. Well, of course, it's gonna make me log in too. All right, 1 second. Yep, it's mandatory.
Good. I mean, those darned IT people.
Yeah. All right. So I'm in my Atlas cluster here. If I wanted to, I could look at my collections. What's up?
I was like giving a talk the other day, and I couldn't figure out how to open my collections. Atlas. Like I did, I swear.
Yeah, so I mean, this is the data that the API consumed from. So it's nothing new. If I went to Stitch, which is, I've been calling it Realm because it's being rebranded to Realm in May. So if I wanted to open up one of my applications, I can go to the GraphQL side of things, and I'd have access to GraphQL queries. If I wanted to know what exists, I can look at what the schema is for the queries and mutations. So it's just a good interface to work with MongoDB. Realm does offer other things beyond GraphQL. So there's functions and triggers as well. So maybe if I wanted to set up a trigger based on any kind of, maybe one of the fields in my documents changed and I wanted to send an email off when that happened, I could do that. So it's essentially just a middleware that you can use between your database without having to code your own.
So this GraphQL there that
Yeah.
that is the hosted GraphQL like interface in between MongoDB and your application?
Yep, and this would be my GraphQL API that I would provide.
Does it generate the schema based on your MongoDB?
So if I go to rules here,
Yeah.
I would.
That was the hardest part for me with
Yeah.
GraphQL was trying to figure out the schemas. How to
So just hit the generate schema. You can give it a kind of pool of documents to choose from. The default is 1,000. It'll look at 1,000 documents because in your collection, you really still don't need to have a rigid schema defined. You could have documents that are all over the place. So it's going to look at a big enough pool and try to identify what the schema should be for GraphQL.
Cool. Queries and everything too, or just?
Yeah, it gives you the queries, the mutations, the schema, gives you everything. So if you wanted to use full GraphQL to create documents, to query documents, you could.
And this is a heck of a lot easier than rolling your own.
Yeah, because it includes it includes authentication too. So you have, I mean,
you authenticate. So you use Atlas to set up all the authentication.
yeah.
Through the GraphQL file.
So it has authentication. It has a JavaScript SDK, or you could use the REST endpoints like I showed in Go. But I mean, otherwise you'd have to create your own API. You'd have to create all of your resolver methods, your schemas. You'd have to define your own authentication techniques, JWT or whatever you plan to use. I mean, it's not impossible. It's just a little more work.
So I guess what would be the advantage of using GraphQL over just directly talking to MongoDB?
It's a familiar technology for a lot of people if you're not a back-end developer.
Right. You would write those post queries in GraphQL as opposed to using
Yeah.
the lower level
Yeah.
SDK stuff. Okay.
Yeah. I mean, if you're a React developer, or I'm pointing out React here. I don't know how frequently React developers are working on Node.js within the companies. I don't know.
Because that's where GraphQL came from, right?
Yeah, I did. I think a lot of people are full stack now, though, right? Are you full stack? You're strictly React, strictly React. So you probably wouldn't be doing MongoDB from, yeah. So there's a use case for it.
Oh, absolutely. Yeah. It's just,
I like the rolling your own.
Yeah.
That's not hard at all.
Off?
It's awful.
Yeah, it is.
Bad joke.
Just summary here. BSON mappings for your data structures, they're useful. I mean, you can. I wouldn't rely strictly on BSON D and things like that. It could get messy, but that's totally up to you. I showed you CRUD, but there's other parts of the MongoDB SDK that you can use as well. So the aggregation pipeline, so that's where you would get into more complicated things like groupings, joins, more interesting type queries than simple finds. There's also change streams. So if you wanted to monitor for database changes in your application in real time, rather than maybe long polling or constantly running queries, you could do that. And then if you're really into database transactions, that's available in the SDK as well. So links to follow. I know that there's a lot of new faces here. TracyDevs.com is the typical landing page for this group. If you haven't already, please sign up for the newsletter. The newsletter, I only send out announcements of the next meetup, and then if this video records successfully, I'll do a follow-up email with the video. So you won't be spammed. You'll just get information about the meetup group. If you feel like you've been spammed, let me know and I'll correct it. You're smiling like you feel like you've been spammed over there, no? Yeah. And then finally, again, the code if you want some Atlas credit as well.